Hey everybody, in this video I'm going to talk to you about identifying characteristics of quadratic functions. You're going to be able to calculate the axis of symmetry, identify the vertex, and root on a graph. So in the last section we looked at standard form and vertex form. Well, mostly the focus was vertex form. And the axis of symmetry is a vertical line that cuts the parabola in half. So if you're cutting the parabola in half, you're going right down the vertex. So if you're in vertex form, it's basically the x-coordinate of the vertex. So if the vertex is at h comma k, remember h is backwards because it's inside. Your axis of symmetry would be x equals h. So here you see in this example, it's at 4 comma negative 10, so x equals 4. You have to say x equals, that makes it an equation for a vertical line. So that's how it is in vertex form. If it's in standard form, you use this little formula, x equals negative b over 2a. So what do I mean by negative b over 2a? Negative of the middle number divided by 2 times the front number. Front coefficient, I should say. So look, here's this graph that I pointed out a couple times already. That is f of x equals 0.5x squared minus 4x minus 2. And so I just wrote check using the axis of symmetry formula. So this is my a, this is my b, negative 4, and this is my c, negative 2. So a is the 0.5. Alright, now that I've got that pointed out, let's just write x equals negative b over 2a. So what's negative of negative 4? You have two negatives, it makes positive. So positive 4 over 2 times 0.5. I know 2 times 0.5 is 1, so this says 4 over 1, which is just 4. So we have x equals 4, and that's calculating it by hand. Look, it says x equals 4 and the graph, see? So you can check your work just by looking at the graph. I'm going to say do it by hand, and then you should just, it's just a quick little negative b over 2, it's just a quick little formula, and then you can just plug it in and look at the graph, and it should reaffirm what you just did. So identify the vertex in the axis of symmetry, and these two problems are in vertex form, so we don't have to do that negative b over 2a, only if it's in standard form. So remember, this is x minus h squared plus k, so my vertex is at negative 1. Flip the sign on the inside. There's nothing on the outside, so 0. And so my axis of symmetry is just x equals negative 1, because negative 1 was the coordinate of the vertex. Alright, that was pretty easy, I hope. Look at this next one. My h is at, see, it says x minus h squared plus k. So my vertex is at 2. My h is at positive 2. My k is at positive 5. So 2 comma 5. My axis of symmetry would just be x equals 2. It's x equals the y coordinate of the vertex. X coordinate. Ugh. Why did I say y? Anyway, to calculate the vertex by hand, solve for the axis of symmetry, then plug your answer back in to get the y value. So this is what I'm doing here. I get my negative b over 2a. So if you want, label your a, b, and c. There's nothing in front of the x squared, so that means a is 1. I have 1x squared plus 2x, so b is 2, and minus 1, so c is negative 1. So if the axis of symmetry is negative b over 2a, I'm going to write negative 2 divided by 2 times a is 1. And so x is going to equal, that's negative 2 divided by 2, that's negative 1. Alright, so I'll just rewrite it. X equals negative 1. Alright, you got your x coordinate of the vertex. Plug it into the function. So negative 1 squared plus 2 times negative 1 minus 1 equals negative 2. So we just figured out the y coordinate, alright? Because if f of x equals that, f of x is interchangeable with y. So my vertex is officially at negative 1, negative 2. And then below, I wrote everything can be checked if you just plug it into the graphing calculator. So let's look at the graph. And so here I have it plugged in, x squared plus 2x minus 1, and I have the vertex labeled at negative 1, negative 2, which is what we just calculated by hand. So, hope that didn't seem too bad. Let's do one more example. You have negative 2x squared minus 8x plus 1, so a is negative 2, b is negative 8, and c is 1. If x equals negative b over 2a, that's going to be positive 8 over 2a. So that negative basically means just flip the sign. You know, if it's positive, turn it negative. If it's negative, turn it positive. And so 2a, I should have written 2 times negative 2. And so that's 8 divided by negative 4, which is negative 2. So your axis of symmetry is x equals negative 2. Alright. What else do I have to say? Plug it in, get the vertex. So negative 2 times negative 2 squared minus 8x minus 8 times negative 2 plus 1 is 9, which is the y coordinate, okay? So your vertex is at negative 2, comma 9. Let's look at the graph to double check. And so here's my graph of the function. There's my vertex clearly at negative 2, comma 9, which is what we got by hand. Okay, let's move on to the next page. Let's talk about minimum and maximum values. This is a screen grab from your textbook, your online textbook, or your actual textbook, doesn't matter. This is just a long way of saying if the graph opens up, meaning a is greater than 0, like not negative, it's positive, so the graph is going to open up, then you have a minimum value because the vertex is the lowest point of your graph. If you have a negative graph, a is less than 0, so the negative a means it's opening down. That means you're going to have a maximum point because that's the highest point you have before it just goes down forever. And then over here, I just wrote the minimum or maximum value is the highest or lowest point on the graph. I guess I should have said lowest or highest point because I wrote minimum / maximum. Oh well, things you realize later. Therefore, it can be calculated or identified by the y-coordinate from the vertex, okay? Because you think minimum, maximum, that's how far high or low, so that's why you're using the y-coordinate, because that goes up and down. This is something called intercept form. See this a times x minus p times x minus q? That is intercept form. And the reason why it's called intercept form is because when you have a quadratic function written like this, guess what? You know what your intercepts are. It should look an awful lot like a factored quadratic function, which is what we started the year with, factoring. So you don't have the power of 2 in there, but you have 2 x's in there. So yeah, it's basically a factored quadratic function. And then with it in intercept form, if there's no number in front of the x, x minus p, x minus q. You remember how you had to flip the h in the vertex form? It's the same thing. So it says minus p. So if p is negative, you just write it as positive, and if q is negative, you just write that as a positive. So p comma q. Those are your x coordinates of your x-intercepts. The y-coordinate would always be 0. How do you calculate the axis of symmetry from that? Well, it's halfway in between your x-intercepts, your p and your q. So if you just add together the p value plus the q value, divided it by 2, you'd get the axis of symmetry, plug that in, and you get the vertex. Alright? Here's an example. Whoa, good yawn. Sorry, I could have paused, but whatever. Let's just keep rolling. This graph, negative 1/3 times x minus 4, x plus 2. So you see how the signs are opposite. Minus 4, positive 4. Minus 2, positive 2. So I said plus 2, minus 2. I said it backwards. Do your p plus q over 2. So what is negative 2 plus 4 over 2 equal? That equals 1. Alright? Why am I pointing that out? Because that's what the axis of symmetry is. 1. So when you plug that back in, negative 1/3 times 1 minus 4 times 1 plus 2, you are going to get 3, which is the y-coordinate right there. And so this one is a maximum because it's opening up, and so that is it's opening down, excuse me, and that is the highest point possible right there, that vertex. So identify the x-intercepts, vertex, and axis of symmetry, and maximum or minimum values. Basically identify everything, sum up everything right here. So this is written in intercept form. So the first thing I can do is identify the x-intercepts, and so my x-intercepts are at, let's see here, plus 3, so that's negative 3. Minus 1, that's positive 1. So I'm going to write negative 3 and positive 1. So you say negative 3, comma 0, and positive 1, comma 0. Okay? Don't just write the number, just write them as a coordinate. So that's my x-intercept. So now let's do the vertex, or sorry, my axis of symmetry. And remember, it's halfway in between those two. So negative 3 plus 1 divided by 2. So I can throw in a little x equals. So negative 3 plus 1 is negative 2 over 2, which is negative 1. So axis of symmetry, x equals negative 1. Let's calculate the minimum or maximum value next. And that is going to be, so I'll write minimum, maximum. Well, what's it going to be? Is it going to be a minimum or a maximum? See this negative? That means it's going to open down. So if it's opening down, you have a maximum. Okay? So I'll circle the word maximum. And then I just need to plug in negative 1 into my function. So I'm going to write negative 2 times negative 1 plus 3 and negative 1 minus 1. And I get 8. So if I got 8 for my maximum value, well, I guess so you could throw in a y equals 8 next to it, then you have found your vertex. So my vertex is at negative 1, comma 8. Alright? So that's everything I asked you to identify. We identified the x-intercepts, we identified the axis of symmetry, we identified that it had a maximum value at 8, and then we were able to identify that the vertex is at negative 1, 8. So go and check your graph. Plug in the function, hit Control T, pull up a few values. Make sure you graph the important values like the axis of symmetry, or I should say the vertex, and your x-intercepts. I went ahead and I graphed mine on my graphing calculator app. I'm using the Desmos app for anybody who's interested. And so here's just a screen grab of that. You see your vertex highlighted at -1, 8, which is what we got, and your two x-intercepts at -3 and 1. So yes, you can check the graph. You can check the graph to get the answers, but I'm really trying to show this to you by hand, and so that way you can do it by hand and just use the graph just to reaffirm what you did, okay? Don't use the graph as the end-all be-all, the graphic calculator, I should say. Calculate it by hand. That's what I'll be grading as a teacher. But anyway, I hope this helped. Stay tuned for additional videos. Like and subscribe if you feel like it. Alright, goodbye everybody.